Okay, here we've got another question that has to deal with the partial and total pressures. So in the question, they're saying that 5.35 liter container has 1.94 moles of gas A and 4.55 moles of gas B at 31.6 Celsius. So they want you to calculate the partial pressures of each gas and then therefore figure out the total pressure. So there's one of two ways we can do this, and either one's going to work. Either one's going to give you roughly the same answer. So the first thing we can do is we can solve for the partial pressures first and then add those up and get the total pressure. So what I did, I converted my temperature into Kelvin so I could use 0.0831. So for A, we would have the pressures what we're solving for, and it's going to be the same thing for A and B, except for the only thing that'll change will be this number of moles right here. So I'll write down these number of moles: 1.94, 0.0831, and then 304.6. Okay, so after you got those two formulas written out, we can solve for the partial pressures of the gases. So for the pressure of gas A, we would have we would have 9.17, let's just say 9.18 atmospheres. And then for B, we would have 831 times, we have 21.5 atmospheres. And again, I'm keeping it in atmospheres right now. For the answer, they want it in kilopascals, so we can just convert that later. So that's the one way that we can find the partial pressures. We can add them up to find the total pressure, which would give us 30.7. Okay, so that's the first way you can do it. The second way you can do it is by using finding the total pressure and then using the mole fraction to figure out the partial pressure. So this, I'm going to put a 1 right here. And the second way we can do it, we can do solving for pressure volume equals my total number of moles. You need to add up the number of moles of A and then B. So 1.94 plus 4.55, 6.49. Okay, so we can figure out the total pressure like this. So 6.49 times 304.6 divided by 5.35. Okay, so we get the total pressure 30.7 atmospheres is my total pressure. Now, the mole fraction is how you would do this is you would figure out the number of moles divided by the total moles. So my number of moles of A was 1.94, and then my total number of moles would be 6.49. So we'd have 1.94 divided by 6.49. Okay, we'd have a mole fraction of 0.298. That would be the mole fraction. Now, if we multiply that by our total pressure, 30.7, we would get 9.17 atmospheres. So we look back and we compare, these two will correspond with each other. And we got the same thing. Now for the mole fraction, that was A. So for the mole fraction of B, the number of moles that we had was 4.55 divided by 6.49 equals about 0.7. Multiply that by 30.7 and we get 21.5 atmospheres of pressure, which is the same thing as what we got up here. So with a question like this, you could do it one of two ways. You can figure out the pressure individually by using each individual number of moles in the ideal gas formula, or you could add up the moles and then figure out the mole fraction and then solve it like that. So the last part of it, you're just converting atmospheres to kilopascals, and I'm just going to convert it with the computer. So 9.18 atmospheres would give you, and this is for A, we have 930.16 for B, 2178.48, and then my total 3110.67. So there you go. You have one of two ways to solve this type of question.